This is the second part of the presentation on value engineering. So the first phase in value engineering is called information phase. In the first part of the video, I've talked about how we start the process by develop the information, and then the second, determine the function, which the output is a list of functions. Now we're going to talk about analyzing and evaluating those functions. The important output of this part is a diagram called FAST diagram. This is a logic chart that organizes all the functions in a product and arranges them in a cause and effect relationship. So to draw this diagram, the very first step is that we need to determine the basic function. Remember, basic function means that this is a function that cannot be eliminated. The product will not exist without this function. So sometimes when we think about a product, we think that the product has a lot of basic functions, or at least there are several. Now in value engineering context, they want us to think about just one most likely basic function. For example, in the Youth Assistance Program study, when they first thought about this basic function, they came up with three functions: eliminate deviancy, identify needs, and assist clients. They think all these functions are basic functions. However, when they are forced to just define one basic function, they think that all these activities that they do in the youth assistance program really actually is intended to achieve this goal, to modify the behavior. So all the activities that they perform is having the objective to modify the behavior of those young people such that when they go back to the society, they will not cause any trouble. They can follow the usual norm in the society. So this is what the team should do. When they think about several functions that are basic functions, they really need to try to define just one basic function. So that is the very first step of drawing a FAST diagram. You can expand the direction of the diagram to the right by following this the logic of how, or the reasoning of how. So for example, let's look at the function of identifying needs. When we want to identify what these young people need such that they can go back to the society performing well and not causing trouble, how can we know what they need? Well, we can say that we need to define their problems first. So defining problems is how we can identify their needs. Now you can ask again, how can we define their problems? One of the ways is to plan a treatment session. So in the sessions, we know what their problems are such that we can identify their needs and finally they can modify their behavior. So if you go from left to right, it's like about how can we do the one on the left? The answer is the one on the right. However, if you go from right to left in this direction, the reasoning becomes why. For example, why we want to plan treatment sessions? Because we want to define their problems. Why do we want to define their problems? So we can identify what they need to go back to the society and performing well. Why we want to identify their needs, what kind of help that they needed, because we want to modify their behavior. So this is how FAST diagram is constructed. We go from left to right with the reasoning of how. We go from right to left, we go from right to left by the reasoning of why. So this is an illustration of a complete fast diagram. So we have dash arrow, here's vertical arrows on the left and on the right. They show the scope of the project. And then we also have the higher order functions and the lowest order functions. Both functions are outside of the scope of the project. It should be noted here that by highest order, it doesn't mean that it is the most important. And by the lowest order function, it doesn't mean that this function is the most unimportant. No, they're not. It's just that they are in this kind of direction. This is the highest order. You can say this is the output of the system, like the final objective that we want to obtain. And then this lowest order function, you can think about it as the input. Okay. And then we have a major primary path here, which the path goes into the basic function, but we can also have minor primary path. So minor primary path here starts from an independent function, or you can say secondary or supporting function. See that you're drawing a vertical lines to that supporting function and then starting a new path for that function. And then sometimes you also want to say that this kind of function is done with such method. The method to perform a function can be called as an activity in this diagram. So going back to the directions in the fast diagram, we have talked about when we go from left to right, it's in the direction of how. So how can we do this? The answer is the one on the right. And then when we go from right to left, it's about why. So why we're doing this function in the center here, the answer is here, the one on the left. And then for the independent function or the supporting function, also for the activity, the relationship can be described with when. It means that when this function occurs, what kind of supporting function that occurs at the same time? What kind of method that we use to perform that function? So the vertical arrows is about when. When this function happens, what kind of secondary function, what kind of method happens. And then the left and right is about how and why. So that's how we read this fast diagram. We read or we construct this fast diagram. Sometimes we can also put some logical relations like and or in a fast diagram. So here, if we say that two functions must be performed at the same time to explain this function, then we use this kind of drawing to say that these two functions have the logical relation of and. However, if only one of them is necessary, so we draw something like this to say that the relation is or. We can also say that even though the relation is and, they are not equally important. For example, here when the lines looks like this, they're still saying that these two functions have an and relationship, but the one on the top, analyze design, is more important than review proposals. Same thing happens here for the relation of or. We can say that we can do this or do that. However, they are not equally important. Monitor performance is more important than evaluate design in this diagram. So this is to summarize how we can establish or draw a fast diagram. First, we prepare a function list. This is from the second part of the implementation phase. So you have a list of function. And then second step is that we are identifying the relationship among all functions. We start with the basic function and then arrange the others with how and why to form the primary path. And then when you have the other functions that are secondary functions that are not placed in the primary path, then you know you need the vertical arrows to say that those are secondary functions. Let's see how we can build a fast diagram for a cigarette lighter example. So step 1, we list all the functions of a cigarette lighter. Here, the complete table from the textbook has like 25 functions. Here, I just show 8 of them. Remember that the function must be defined in 2 words. The first word is a verb and the second verb is a noun. So here are the list of all functions of a cigarette lighter, and then the main function of this lighter is produce flame. And then next we start building this fast diagram by going to the right with the question of how or reasoning how, and then going to the left with the reasoning why. So start from the basic function produce flame. We can say, for example, why we want to produce a flame. The answer is we want to ignite a cigarette. And then how can we produce flame? Ignite the fuel. Same as before, we keep going to the right by asking how and then put all the other functions, if possible, on the primary path. Here you can see that to ignite the fuel, we need to do these 2 functions. The relation is and they're both equally important. We must release the fuel and then we must produce the spark. We must do both of these functions such that we can achieve this igniting the fuel. To complete the fast diagram, we do the step 3 in which we put the secondary functions on top of the functions in the primary path, and then we also put the activity if it is necessary to explain how we perform a function. So this is the complete diagram for a cigarette lighter. Next, we are going to create a cost function worksheet. Here in the first column, we list all the components of a pencil. By the way, we are using the example of a pencil here. And then the second column, we simply list the cost of each component of a pencil. So for example, the eraser costs 0.43 cents. So we know that the total cost to produce a pencil is 2.92 cents. Now this cost function worksheet wants us to break down the cost of a component into the cost of each function that the component supports. For example, the body of a pencil costs 0.94 cents. The table wants us to justify this 0.94 cents is used to perform which functions and how much for each function. The design theme then determined that the body of a pencil supports the function of transmitting force, displaying information, and support the lead. So the existence of the body is used 50% of its existence is used to transmit force, 40% is used to support the lead, and 10% is used to display information. With that kind of distribution, we also distribute the cost of 0.94 of the body into these 3 functions. Because the body is mostly for transmitting force and supporting the lead, so the cost for this function with respect to the body component is significantly higher than the cost of displaying information with respect to the component of the body. So this table shows us that, okay, the body costs 0.94 cents. Now we're trying to distribute this 0.94 cents to see how the cost distributes to all the functions that it supports. Here in this table, we know that most of the cost of the body is used to perform the function of transmitting force. So once we've broken down the cost of each component into each function, we can see that the total cost of each function. It's interesting, right? Now you can have the total cost of each function. Here in the case of the pencil, I think the total cost of the make marks function is the biggest. It takes about 40% of the total cost of the pencil, which makes sense, right? Because a pencil is used to write something, to make marks on the paper. So this function should have the highest proportion of the total cost to produce the pencil. The next thing the table wants us to fill is that what is the best cost that we know to perform each function. So for each function, we think about what is the best alternative out there with the lowest cost possible to perform such function reliably. So for example, we know that the option to make marks, it doesn't have to use pencil or anything. It's just any method that can be used to make marks. The lowest possible cost to perform this function is 0.8. Now we know that there is a potential of 0.4 cents dollar to improve this function. The result from the cost function worksheet can be embedded into a fast diagram. So for each function in the fast diagram, we can include the current cost that we have, and then the best lowest possible cost that is possible for this function. So after we add these values, the diagram will be richer because we can see directly what is the cost of each function, which function has the highest cost, which function has the highest potential saving, and so on. So the implementation phase ended with the output of a fast diagram. Next, we are going to talk about the next phase in the value engineering. Is called creative phase. So we are starting this phase using the output from the fast diagram. From the fast diagram, we look at the functions that have high profit improvement potential. So for those functions with high potential to improve, because the current cost is still much higher than the possible best cost, for those kind of functions, we try to develop the alternative solutions. The method that is usually used in this creative phase is brainstorming. So here, any idea is acceptable. And then there's no discussion is allowed during the brainstorming, such that people are encouraged to just throw out ideas. The more ideas, the better for this stage. For each of the function that has a high profit improvement potential, we ask what else can perform this function. For example, if we have a function of enhancing the appearance of something, we ask what else will do this job to enhance the appearance. You can see that there are several ideas here and they vary a lot, starting from something like using plastic material, something like the shape, using the curves instead of sharp edges, and then also somebody say use multicolor paint, and so on. So this is the result of the brainstorming in the creative phase. We get a lot of ideas, as many ideas as possible. No discussion is allowed, we're just collecting ideas. Based on the ideas in the creative phase, we are going to the evaluation phase. At this stage, the ideas that are generated freely in the creative phase are evaluated. It is important to note here that the objective is not to discard ideas, but we try to look for the good in each idea. Which means that we're not trying to say these ideas will definitely not work and we just throw away that ideas. Instead, we're trying to think, how can we make this idea work? What is good about this idea that we may take? So we always try to be positive with each idea. Now the evaluation steps might be described as follows. So the very first step is that we're trying to eliminate the ideas that are obviously not useful. Although here we are still trying to be open-minded with each idea. What we can do is that we ask each team member to vote, keep or discard an idea. No discussion is allowed. Just keep or discard. Even though just one person say keep the idea, we're going to keep the idea because we only want to eliminate the ideas that are obviously not useful. On the second step, the team discussing the remaining ideas on the list. The decision of this step can be keep the idea, discard an idea, or combine some ideas together. And then the third step is that among the remaining ideas, whether it is the original ideas or the combined ideas, we try to select the best alternative among them. Basically, we try to compare what are the advantages and disadvantages of each of the remaining ideas. We can also perform a voting from each of the team members to select the best idea. So as an example here, let's say we have 5 ideas here, and then we can do such a paired comparison like in this table. So here we compare, let's say, A and B, and then we say B is moderately better than A. So means that B is better, and the number 2 means B is moderately better. For the comparison between B and C, we say that B is significantly better than C. To select the best ideas among these 5 ideas, we just sum all the points that idea gets. For example, here B got 2 plus 3 plus 2 plus 1. So it's like B got 8 points. I think B is the best idea in this comparison. Although if you look at B idea, it says reducing the length of the lead. So in other words, this idea is about reducing the length of the pencil. It's quite strange, right? So anyway, it is related to, again, the objective of this team. What do they want to improve? Maybe their current pencil is too long, so that's how they came up with this idea, and then they think that this idea is good. Remember that this idea originates from the function of make marks, which has the highest proportion of the total cost of the pencil. Once we've selected the best idea, we're going on with that idea to the planning phase. In the planning phase, we're going to develop the best ideas in detail. So you may keep the best idea and the second best ideas just in case that the best ideas is rejected. So by developing ideas in detail, it means that we are trying to determine the cost more accurately by getting the latest data of the cost from all the related people. We discuss the proposed solutions with relevant people and develop a cooperative atmosphere with everyone because we want this solution to be accepted and the project to be successful. Another important thing in this planning phase is that we need to determine potential roadblocks. For example, in the idea of reducing the length of the lead, we're going to make the pencil shorter than it used to be. The main roadblock is that it is differ from traditional design practice. We need to think about the action that is required to convince people that this solution will work. So for example, first, we show that people seldom use the pencil full length. Okay, so we are going to make a shorter pencil and we say it's okay because people never use the full length of the pencil anyway. So why we make a long pencil? So that might be an argument. We can also say that customer actually cares more about a good style of the pencil, that it looks nice and attractive, and then also they care more about the lower price. So as long as the cost is lower and it looks good, then if we can show that customers are okay with that, then maybe we can say that we can overcome this roadblock, even though our idea is about reducing the length of the pencil. Once we have developed the solution or ideas in detail, we go on to the reporting phase. Most of the times, the design team needs to report their ideas or solution to people in a higher position who will make the decision whether this idea can be implemented or not. So in the reporting case, some important things to be noticed by the design team are first, when reporting the project, they need to cover all the facts. What is the current product looks like, what is the current cost, and so on, and then show the basic changes that are proposed for the solution. The team also needs to justify the recommendation, all the advantages and all the disadvantages, including the roadblocks, and show that the design team has already considered all the disadvantages in their solution or proposal. The design team also needs to say what are the effects for the company. For example, before and after cost, what is the potential saving for each unit of the product, and so on. And then finally, the design team needs to discuss the proposal with all people who will be affected by the idea. For example, the people in the production planning, people in the production line who will actually produce the product that is proposed. The final step after the solution is accepted is implementing the solution. So that's the end of the value engineering approach. Now you can see that over all these phases, really the emphasis of value engineering is in functions. We start by listing all the functions. We break the cost into each function. We try to see which function has the highest potential to be improved. We develop ideas based on the functions with the highest potential. We evaluate the ideas and then we try to design those ideas in more detail. But really the emphasis is about functions. So that's the end of the presentation about value engineering. Thank you.